Okay, in the first video, we looked at the hub, which is how you control your telescope directly, and how you put things in the calendar and write projects and look at the weather. Then we had a look at the scheduler just briefly. We didn't go into detail. And how do you request uh, objects to be seen? So those two videos cover how do you collect your data. The other part of that is what happens after it's collected. So if you look at the hub, you will see the pretty pictures that come in, particularly of the small Magellanic Cloud, or the lagoon over here. Clouds came in early this morning. There's small Magellanic Cloud from the other video. When I look too low on the horizon, and then there's M20, there's some lagoon, and whatever that cluster is in the center. So you see, we've got all this wonderful data. What happens? Well, in the past, you'd have a hard drive full of files, and if you are not well attuned to how astronomy works, you would go, what is a FITS file? I don't even know what that is. How do I open it? And why is there a terabyte of these files? And they all look a bit weird. Well, we solved that problem. So if you know what if you understand what I'm saying, good. If you don't worry about it. So next sentence may be in a different language. But the system organizes its own flat fields, biases, darks, bad pixel maps, and variance frames. Now these are all the things that you need to really make your images be cleaned of any noise from the camera or bad pixels in the camera, and to get an idea of the variation across the frame for making accurate measurements. Okay, that's over. You either understood what I said or you didn't. It doesn't matter. Because what happens is that all happens automatically. The collection of all these images and the application of all these images are all automated. But then what? Then the images are put in this thing called the data center. So in your scheduler arbiter thing, when something is successful, you'll be able to go in there, have a look at a quick look at the images that came in. But that's generally kind of a front end looking down into this bigger thing called the data center. Now, data center is where we store all of the images that are taken by all of the telescopes by all of the users. I mean, the initial reason to have it is so people can get their data. So you have the telescope, it takes an image, it does some of that instrumental noise stuff, then it flings it off to a pipeline machine, we call them, which then further processes it, measures all the stars in the image, stacks them, does lots of fun stuff, makes JPEGs, PNGs, and then once it's finished there, then it sends those final products off to the data center. So here we are. So in here, this is a bunch of search things. You can search by object name. By default, your username will be in here, so you'll search by username. Position in the sky, what filters, as in what colors of images do you want to have a look at, what observatory, you might only want to see things from one observatory, whether they're stacked or not. A few things like shortest and longest exposure, how high resolution the image is, and how low in the sky it was observed between particular dates. So let's press search. Because I haven't put a start or end date, this will probably just give me everything I've ever had. Once we've searched, you see down here a long list of every file I've ever taken, basically because I never pressed anything to trim down the search. But you see it's pretty quick anyway. I mean, there's probably thousands and thousands of files here. And you can come here and you can just, there's a little thumbnail so you can see the image. You can click on the image and it pops up and it gives you a bit of a higher resolution version. And if you're kind of interested in looking deeper, you can click this preview button, which gives you an even higher resolution image. These are still not the final image, these are previews. So if I come back here, you can click the header item, which really you only need to do if you know what you're doing and are looking for some kind of obscure piece of information you might want. But this is kind of like the metadata behind the image that stores all the information about the image, like how cold is the temperature, how cold is the camera, 5 degrees. And the other thing is we have these data files P and S. That's two types of measuring stars. I'm not going to go deeply into the two different types and why we use them, but there's the celestial longitude, RA, the celestial declination, celestial latitude, which is called declination. So these are all star positions. And then basically these columns are how many bits of light did we measure and how sure are we about it. So you get these files where the stars are all measured for you already. So you can see lots of data in here. So depending on your settings, you may not send up every single raw file that you ever use. Each of these images here is actually not the final image, it's actually one of the components of the final image. So we've been doing a lot of stacking. So I will just make it show only the stacks, and you'll notice the name is white there, NextAstro SMC blah blah blah, that's white. If I go to stacks only and search, you'll notice they come up blue, because this is the final image. So I ask for a 300-second exposure, and here it is, my final image. So these are some of the blurry ones of the wall that we took. Let's find something a bit more exciting. I want to find Ida Karina. It's earlier on in the night. Okay, let's have a look at this one. There we go, that's a lagoon. Very nice. So this is the preview. If I want the actual raw image, I can press this and it will give me a FITS file. If you know what a FITS file is, super duper. If you don't, you may never actually click this button. So here allows you to go and look through individual images and sort through them. So that usage kind of describes how you just get your data and kind of perhaps bring it down to your computer. You can select all, select none, select just the stacks, select no stacks, and then when you've selected your image with the little boxes, as you're probably familiar with from many other programs, you can go download and say you could download all this type of photometry, which is star measurement, or that type of photometry, which is star measurement. If I click it, you'll see file collection process here. It'll get all the files together, zip them up, and it'll pop up here in my downloads folder. Same with the FITS files and FITS and PNG, JPEGs. If you want just to download everything in that search, you can just press select all and download. Now that's fun in and of itself. So there we go. There's my files downloaded. But the interesting thing that we're trying to move away from is downloading everything. You don't need to download all this stuff onto your computer. You should only have to download what you need, and sometimes you don't need to download it at all. So there's over time we're going to increase the number of things that we do on the computer. So the data center itself is a computer with hundreds of CPUs and terabytes of RAM or whatever, and we can keep on adding capacity to that computer over time. So, and it's always going to be way more powerful unless you're quite well resourced. It's always going to be far more powerful than the computer you're using. And if you are in the context where you have students using computers, it's always going to be mind-bogglingly faster than whatever student computers are available. So we're moving to the use scenario where you do as much processing online as possible. So I'll show you an example of what we can do if you kind of know what type of processing you want to do. So we we do a bunch of things. There's some color imaging stuff. There's double star stuff. There's variable star stuff and exoplanet stuff. So I want to show an example of an exoplanet because you actually use the variable star tool to get the transit for the exoplanet. So yes, you can download your images, and yes, there's color imaging tools, and there is stacking options, and mosaicing is on its way. But really, perhaps you want to measure an exoplanet transit. So I magically already know in the database where there's a good transit, just so that we can skip to the chase and see a good sample. So no, it wasn't in July. It was June. So let's go June. So I know it was on the 5th. So I'm just going to set the 4th to the 6th. The object was, it was a WASP object. So that should pick it up. I only want the non-stacks. Alright, that should pop up my WASP dataset that I'm looking for. There we go. So, see, we've got this frame here. And the WASP target is this star. Generally, if you ask for something to point at something, it'll be in the center of the frame. So we've got, here we go, here's this star. So if we go up here and we select all, 1,110. That's a lot. You could download 1,100 60 megabyte FITS files. Look at them all. Or you could leave them on the server, which has terabytes of space and RAM and CPUs, and ask the server to do it for you. So that's what we're going to do. We're going to go PSX to AstroSource. PSX is a type of star measurement. So each of these images have already had their stars measured. So we're going to start from there. So we'll go PSX to Photoshop. Not Photoshop, AstroSource. AstroSource is a tool we've been developing over the last decade or so. If you look at student research projects in the JAVSO, you will find it frequently referenced. So this is the star I'm interested in. So I'm just going to, I've already typed it in before. So you can see the star you're interested in. In the future, it'd be nice if I make it so you can click and it pops in here, but that's not what we're doing at the moment. So we've got the RA and deck of the exoplanet. We're not going to look for the period. That's for period hunting for variable stars. And we're not really interested in the magnitude calibrations, although we can do that. So it'll automatically calibrate in whatever filter you're in, B, V, I, Z, whatever you like. So here we go. We're just saying this star. That's all we are interested in at the moment. If you press process of AstroSource, what this does is you could have reasonably downloaded the 1100 files onto your computer, installed AstroSource, installed Python, kind of pull your hair out a little bit because that's just what you do with astronomy packages. Or you can get it doing what it is now, which is just running on the server where it's already installed, it's already tested, and it's on us to actually do the bug fixing. So I usually hold down the end button on my keyboard. So this is actually just outputting what the server's doing to your browser. So it's going to take a little while because it's 1100 files. AstroSource is this thing that will take all the measurements of the star brightnesses, find your comparison of stars, and if you tell it where the star is, it will do the most optimal kind of photometry and sorting out of photometry to get your light curve out that there possibly is. Now, it doesn't take that long, but I'm not going to make you sit here waiting for it, so I'm going to pause. And it's 7:46, and actually, it's still 7:46. I thought I was going to say it a couple of minutes later, but it's already done. So here we go. AstroSource analysis complete. You can look at the output once you learn what it all means. And here we go, run complete. Here's the results. You can show V1, and then here is the exoplanet curve. You can download that thing in various formats. So there's XL for exotic, for Paranzo, don't mind using. But the interesting thing might be that's a variable star thing. So you can imagine if you have an RL array and you set it to do calibrated magnitude, off you go, you've got your RL array curve. Here we have our exoplanet curve, which allows us an opportunity to send to Exotic. So Exotic is from NASA and Rob Zellum and co. It's a piece of software to fit exoplanet transits to your data. And it's lucky it's remembering the values for me. It's part of the process that you have to fill in this inits file, which is the initial data that it needs to fit the exoplanet transit. So just putting in the values from before. You can save your inits file to your user space on the archive as well. You have a little drive where you can save things, but I'm just going to go save inits and run exotic. And so now it's doing the same thing again. So we went from the archive where we selected all the 1100 files, sent it to AstroSource, and then AstroSource had it, and we kind of turned the wheel, shook it around, did all the measurements, got some results. But now we're taking that results and we're putting it into exotic, and it's doing the same thing. And we will soon see the text from exotic turning up here. Behind the scenes, sometimes it takes a little moment for software to spin up, especially if it has to update. So here we go. It's already chunking away. So exotic does this thing where it makes a nice little picture, which doesn't quite work with the how the web shows the log, but you can see this line here, if you have used exotic before, will make some sense to you. It is honing in on fitting the curve to your data. So it is 7:49. It was close. It's now 7:50. So it took about a minute to run this. So you can see exotic has successfully run. It has given you a final planetary parameters. If we zoom back up to the top, the results are, as always, summarized up the top. So here you have your exoplanet transit curve, exotics fit to it. You have the final planetary parameters, the triangle database, and you can always just download the whole directory onto your computer and look through it. As you do, it has all of the exotic-y things that exotic produces ready for you to submit to the AAVSO, etc. So you can see the archive is a tool just to get your data, but it is a tool where you will be able to do lots of different stuff and more as time goes on. So you have uploading to Google Drive, double star measurements, color imaging stuff, which there'll be a few more buttons there today. But basically you can send frames off to either Photoshop online, or you can get them made into a PSD to open in Photoshop or GIMP and download it. So this is where you get your data, but it will be an expanding area of things you can do with your data online without even having to download it. So that's why it's called the data center. It's that place to store data, but also a place to do stuff with data. So data center.